Astronomy 101, the introductory guide to enthusiastic stargazers. To become an interplanetary species, we need interplanetary notions. Written by Darrell Ason. Narrated by Wright. Introduction. Astronomy is a natural science that studies celestial objects such as moons, planets, stars, nebulae, and galaxies, as well as their physics, chemistry, mathematics, and evolution, as well as phenomena that occur outside of Earth's atmosphere, such as supernovae explosions, gamma-ray bursts, and cosmic background radiation. The visible light, or more broadly, electromagnetic radiation, is the primary source of information about celestial bodies and other objects in astronomy. The observable region of the electromagnetic spectrum can be used to partition observational astronomy. Some sections of the spectrum can be seen from the ground, whereas others can only be seen from very high altitudes or from space. The oldest form of astronomy is optical astronomy, commonly known as visible light astronomy. Optical images were first created by hand. Photographic equipment was then used to create photographs throughout the late 19th century and early 20th centuries. Digital detectors, particularly charge-coupled devices, are used to create modern images, CCDs. Although visible light has a wavelength range of around 4,000 to 7,000 Hz, 400 nanometers to 700 nanometers, the same technology is used to observe some near-ultraviolet and near-infrared radiation. Radio astronomy is the study of radiation having wavelengths longer than 1 millimeter. In contrast to most other forms of observational astronomy, radio astronomy allows the measured radio waves to be regarded as waves rather than single photons. As a result, measuring the amplitude and phase of radio waves is relatively simple, although doing it at shorter wavelengths is more difficult. While some radio waves are produced by celestial objects as thermal emission, the majority of radio emissions observed from Earth is synchrotron radiation, which is produced when electrons oscillate around magnetic fields. At radio wavelengths, a number of spectral lines produced by interstellar gas, including the hydrogen spectral line at 21 centimeters, are visible. At radio frequencies, a wide range of objects can be seen, including supernovae, interstellar gas, pulsars, and active galactic nuclei. The detection and study of infrared radiation is the subject of infrared astronomy, wavelengths longer than red light. Infrared radiation is substantially absorbed by the atmosphere, except at wavelengths close to visible light, and the atmosphere produces significant infrared emission. As a result, infrared observatories must be built in high, dry locations, or in space. Planets and circumstellar disks, for example, are too cold to emit visible light. Thus, the infrared spectrum is valuable for understanding them. Longer infrared wavelengths can penetrate dust clouds that block visible light, enabling for observations of newborn stars in molecular clouds and galaxy centers. Infrared radiation is strong in some molecules. This can be used to investigate chemistry in space, specifically water in comets. The term ultraviolet astronomy refers to observations made at ultraviolet wavelengths between 10 to 320 nanometers. Because the Earth's atmosphere absorbs light at these wavelengths, observations at these wavelengths must be made from the high atmosphere or from space. The study of thermal radiation and spectral emission lines from hot blue stars, or OB stars, that are exceptionally luminous in this waveband is best suited to ultraviolet astronomy. Other galaxies' blue stars have been the subject of various UV surveys. Planetary nebulae, supernova remnants, and active galactic nuclei are some of the other things that can be seen in ultraviolet light. However, because ultraviolet light is easily absorbed by interstellar dust, UV measurements must be adjusted appropriately. The study of celestial objects at X-ray wavelengths is known as X-ray astronomy. Synchrotron emissions generated by
Sample complete. Ready to continue?